Hi, welcome to the first trigonometric tutorial. Today's tutorial is titled Basic Trigonometric Identities and the Cartesian Plane. We are going to be looking at the basic trigonometric identities and how they translate onto the Cartesian plane. Note that the Cartesian plane is just a system of axes. In terms of what you need to know, you need to be familiar with your grade 10 work on trigonometry, and I'd also recommend you go through the section I've included called Using Your Calculator. Reference to this is made in the DVD workbook. What is trigonometry? Trigonometry is a science that looks at the relationship that exists between the angles and sides of a triangle. Initially, this science was developed primarily around the right-angled triangle, but has been further developed to include almost all triangles. We will begin by looking at the basics of a right-angled triangle and progress on to the three basic trigonometric functions of sine, cos, and tan. Take a look at this right-angled triangle over here. Firstly, the most important thing about a right-angled triangle is the fact that it has a right angle in it. And I'm going to put that over here. Opposite the right angle, the side opposite the right angle is always the hypotenuse. Now, I'm going to draw in an angle theta. Theta is just a Greek letter that can denote an angle. Note that we could use theta, we could use beta, we could use alpha. We could also use any other variable. We could use x, y, we could use z, s, t, up to you. The side that is opposite that angle is referred to as the opposite side, and the side that is next to that angle is referred to as the adjacent side. So in this triangle that we have now, of theta, the hypotenuse is always the hypotenuse of the right angle triangle, the opposite side is over here, and the adjacent side is over here. I'm now going to change that slightly. I'm going to look at this top angle over here. Let's call that S. Of angle S, this side is now the opposite side. This side is now the adjacent side, due to the fact that the opposite side is opposite angle S, and the adjacent side is adjacent to or next to angle S. The hypotenuse is still the hypotenuse. Now remember, earlier I said that trigonometry is a set of relationships that exist between angles and sides of a right-angled triangle. We are now going to look at those relationships. The first relationship we will be looking at is that of sine. Sine deals with the relationship between the opposite side and the hypotenuse. Sine of any angle in a right angle triangle is equals to the opposite side divided by the hypotenuse. Cos is the relationship that deals with the adjacent side to an angle of a right angle triangle and the hypotenuse. Therefore, cos of an angle is equals to adjacent over hypotenuse. Tan is the relationship that deals with the opposite side to an angle in a right angle triangle and the adjacent side to that angle. Tan of an angle is equals to opposite over adjacent. Let us see how this translates to a right angle triangle. Again, I'm going to use the right angle triangle that I used above. If I draw in theta over here, sine of theta will equal opposite over hypotenuse cos of theta is going to equal adjacent over hypotenuse, and tan of theta is equals to opposite over adjacent. These relationships always hold true, and I want you to memorize this. One way that I learned to memorize this was at school, where I learned this rhyme: silly old hens cackle and howl till old age. You are welcome to learn any rhyme you need to, or just learn it as is, but always remember that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. We are now going to look at some simple calculations involving the basic trigonometric functions. I want you to have a go at the following examples. Press pause on your DVD player, and when you return, we'll go through it together. The first one I gave you to do read sine of 40. Now sine of 40 degrees, if you punch it into the calculator, you're just going to literally type sine 40. That's going to give you an answer of 0.64278. So I'm just going to round it off to 0.64. The second one was cos of 80. Cos of 80 degrees. Again, just type it into your calculator as cos of 80, which will give you an answer of 0.17. Number 3, tan of 20 punched into a calculator is equal to 0.36. Now if you are not getting the answers that I'm putting up here, I would suggest you go through the tutorial I've included called Using the Calculator, because possibly your calculator is not in the form DEG, which stands for degrees. The next one, sine of 50 is equal to 0.76, actually 0.77 if I round it off. Number 5, cos of 40 is equal to cos of 40 is equal to 0.77. Where have we seen this one before? Haha. Notice that sine of 50 is the same as cos of 40. Just out of interest, sine of 30 degrees, if you punch that into your calculator, is going to give you an answer of 0.5. Type in cos of 60. That's also going to give you 0.5. Look at the relationship 50, 40, 30, 60. I'll give you one more. Sine of 10 degrees is equal to 0.17, which is exactly the same as cos of 80. Something for you to think about. Sine of 50 is the same as cos of 40, sine of 30 is the same as cos of 90, and sine of 10 is the same as cos of 80. Keep that in mind. The next 5 that I gave you to do were the opposite, where we had to use the inverse function. The first one was sine of x is equal to 0.5. To get x, we're going to say x is equal to second function sine on the calculator of 0.5, which if I type that in is going to give me 30 degrees.